दिन बच्चों। आज हम लोग पुराने टॉपिक को आगे बढ़ाएंगे, कॉम्प्लेक्स नंबर्स। लास्ट क्लास में हमने कॉम्प्लेक्स नंबर पढ़ा था। कॉम्प्लेक्स नंबर इज अ नंबर इन द फॉर्म ऑफ a plus iota b where a and b are real numbers. A is real part, b is imaginary part of the complex number. Then we have moved further and we have learned how to add two complex numbers, how to find out the difference of two complex numbers, how to find out the conjugate of a complex number, how to multiply two complex numbers, how to find out the modulus of two complex numbers. So we have learned so many things. Now it is our turn to move further, and we start today's class with some example on the inverse of a complex number. So we have z plus equals to a plus iota b, and z inverse can be calculated as 1 upon a plus iota b, that is multiplicative inverse of z. And to simplify it, we multiply the numerator and denominator by the conjugate of a plus iota b, that is a minus iota b. So when you multiply these in the numerator and denominator, we are going to get a minus iota b upon this, and you have z into z conjugate equals to mod z square, that is a square plus b square. So finally you can conclude that the multiplicative inverse of a complex number z inverse equals to z conjugate upon modulus of z square. Now let us take an example, z equals to 3 plus 4 iota. In this case, first we evaluate z conjugate, it is 3 minus 4 iota. Then we will evaluate modulus of z square, that is 3 square plus minus 4 whole plus 4 whole square, and that is equals to 25. So what is z inverse? Using this formula, z inverse will be z conjugate upon mod of z square. So you can get the answer very easily, 3 minus 4 iota upon 25. So this is how we have calculated z inverse. Now it is turn for a complex number to be represented on a plane. So a plane which contains complex number, or a plane in which every point will correspond to a complex number, or every complex number is corresponded by a particular point in a plane, is called Argand plane or complex plane. In this plane, I have taken a complex number x, z equals to x plus iota y, which has real numbers x and y. So real number x and y will correspond to a point. Then I have taken this point as P. So this is one way to represent this plane, and in this plane x-axis is replaced by real axis, y-axis is replaced by imaginary axis. Now if I want to find out the distance of point, this complex number P, from the origin, I am going to get under root x square plus y square. This is also modulus of z, and we will represent this as r. And if I take this real axis or x-axis as initial line, then the angle formed by this line with this line OP is theta. So it is very obvious, by this unique value of r and theta, we will represent a unique point. A unique point एक इकलौता ऐसा पॉइंट होगा जो एक खास डिस्टेंस ओरिजिन से, एक खास डिस्टेंस पे और एक खास एंगल से रियल एक्सिस के साथ होगा. There cannot be more than one point. There must be. So any point is uniquely represented by r theta as it was represented by xy. In this case, we are taking the distance from x-axis or y-axis, or in this case from real axis and from imaginary axis. Now we have a new term, that is theta. R is old, r is modulus of z. New term theta. This theta is known as augment of z or amplitude of z. How to find out theta? So tan theta can be given by y by x. You can see from this diagram, this is a right angle triangle. In this, tan theta can be written as y by x. What more relations you can derive from this diagram? You can derive that y is equals to r sine theta and x is equals to r cos theta. So these two more things can be derived, can be driven from this diagram, and using these two things, you can say one thing, that this complex number z equals to x plus iota y can be written as r cos theta plus iota r sine theta. And this cos theta plus iota sin theta. And finally, this form, that is r into cos theta plus iota sin theta, is called polar form. This is when you represent a complex number in x plus iota y in this form, it is called polar form of the complex number. Now let us come back to the amplitude. Amplitude of or argument of z is must be and with an interval of 0 to 2 pi. इस 2 pi का ही interval इसमें लेना होगा, like 0 to 2 pi आप ऐसा ले सकते हैं. But right now we are taking argument of z between minus pi to pi, and this is called principal argument. Argument of z is also represented by arg z, arg-z. Now this diagram will help you to find out the value of argument in different cases. When it is in first quadrant, you have tan theta equals to tan alpha, because in different quadrants you may have tan theta equals to different values. If you solve this, and you may get root 3 can be written as tan pi by 3, or minus root 3 can be written as tan of minus pi by 3, or 10 pi minus pi by 3, whatever. So you can get a number of equations like this. So what is the value of theta? In first quadrant, if it does this complex number lies, then theta equals to alpha after getting this equation, and in second quadrant it is theta equals to pi minus alpha, and in third quadrant it is theta equals to alpha minus pi, or in fourth quadrant it is theta equals to minus alpha. Using this concept we will move further. Now we are going to take some examples of conversion of a simple complex number into polar form. We have complex number x plus iota y equals to r into cos theta plus iota sin theta. This is the polar form. तो पोलर फॉर्म के लिए हमें क्या रिक्वायरमेंट है? पोलर फॉर्म के लिए हमें r चाहिए और थीटा चाहिए, तो हमारा काम हो जाएगा. तो पोलर फॉर्म के लिए सबसे पहले हम देखते हैं इस क्वेश्चन जो फर्स्ट एग्जांपल हमारा 1 plus root 3 iota, इसमें हम r और थीटा की वैल्यू कैसे इवैल्यूएट करते हैं. तो what is r equals to under root x square plus y square. So you have r equals to under root 1 plus 3, that is root 4, that is equals to 2. Now what is theta? How to find out theta? So you have tan theta equals to y by x, that is root 3 by 1. If you compare this with x plus iota y, x equals to 1 and y equals to root 3. So it is root 3 by 1, and that is equals to 10 pi by 3. You have tan theta equals to 10 pi by 3. It is in the first quadrant. ये पहले quadrant में है, तो आपके पास tan theta equals to 10 pi by 3, that gives you theta equals to pi by 3. Now the required complex number in the polar form is r into cos theta plus iota sin theta. So the polar form for this complex number is r into cos pi by 3 plus iota sin pi by 3. This is your answer. Now come to this second example. So look at this. It is minus 1 plus root 3 iota. X, that means real part, is negative, and y is positive, that means imaginary part is positive. Certainly it is going to be in second quadrant. ये सेकेंड क्वाड्रेंट में होगा. यहाँ से आपके पास r equals to आ जाएगा under root x square plus y square. If you compare this with x plus iota y, you are going to get x equals to minus 1 and y equals to root 3. So the value of r is minus 1 whole square plus root 3 whole square, and that gives you again 2. Now come to the theta. So what is tan theta equals to? Tan theta equals to y upon x, that is root 3 upon minus 1. That can be written as minus 10 pi by 3, because it is minus root 3, and we know that root 3 equals to 10 pi by 3. As it lies in the second quadrant, so just recall that diagram we have just given few minutes ago. So with using that diagram in second quadrant, you will write down tan minus tan alpha as 10 pi minus alpha, that is 10 pi minus pi by 3. So you have theta equals to 2 pi by 3 by comparison, as it lies in second quadrant. Now the polar form of this complex number will be 2 a sine 2 pi by 3. Now come to the third case, that is z equals to -1 minus root 3 iota. तो सबसे पहली चीज आप क्या देखते हैं, what you look at first, in which quadrant does it lie? So x is negative, y is negative, real and imaginary both part is negative, so it lies